researcher at the Tyndall Centre for Climate Change Research over at Manchester University, and it's heartening to come across the panel and see even more people interested in climate change than there are keen in Manchester at the moment. What I would like to talk to you about is mapping, using the techniques that we have worked on at Manchester University, techniques of emissions budgeting and cumulative carbon accounting, to try to take you on a journey from the rhetorics, the international and the government rhetorics of aspirational climate change, through to the reality of the present situation that we face, and then give you a sense of the types of policies and the scale of the challenge that really is appropriate. And then I think Andrew can talk to you at the city level about the types of responses that are very positive. Okay, so first of all, the rhetoric. So the Copenhagen Accord is a major document that came out of the negotiations in 2009 for the United Nations Framework Convention on Climate Change. It had assent of most of the nations in the world. I think there are 188 signatories to the Copenhagen Accord at present. And the wording of the Copenhagen Accord was echoed again last year by the G8 world leaders. And that is that we would have international commitments, each country to make a fair contribution to hold the increase in global temperature below 2 degrees Celsius, and to take action to meet this objective consistent with the science and on the basis of equity. And there are two key foundations that almost all world governments, and certainly the most powerful world governments, have signed up to. This is kind of being devolved down in the UK into a range of different policies. An example here, the Low Carbon Transition Plan states that to avoid the most dangerous impacts of climate change, average global temperatures must rise no more than 2 degrees Celsius. And it's 2 degrees Celsius that is not a scientific conclusion, that's a political conclusion of an acceptable, the threshold between an acceptable degree of climate change and an unacceptable, a dangerous degree of climate change. And clearly that is a broad average figure and doesn't represent the impacts or the challenges that any particular locality or any particular nation would face. It's not a scientific decision that there is a clear, hard and fast 1.9 degrees is okay, 2.1 degrees is not okay. But this is a kind of a political decision taking recommendation and advice from the scientific community that 2 degrees Celsius would be our global target, avoiding 2 degrees Celsius. Okay, so that sets out our mitigation question. What emissions reductions give us a good chance of staying below that 2 degrees Celsius boundary? And it's with our emissions accounting, our cumulative emissions accounting tools, that we try to answer that question. Then there's another question that arises from that, and for adaptation, for living with the changes, the quantity, the amount of climate change that we see already, the amount that we've committed ourselves to, and the amount that might be realised in the future in the absence of effective mitigation. What temperatures or climate should Sheffield, should Manchester prepare for? Okay, so the question now is, how consistent are these 2 degrees Celsius intentions with current emissions trends? This is the reality. So, brief history of where our emissions trends on global fossil fuel and cement CO2 emissions have gone. The UN Climate Change Panel, the Intergovernmental Panel on Climate Change, was established in 1988 when emissions were around 20 billion tonnes of CO2 per year. And then this panel established the scientific consensus and the broad case that we are dangerously interfering with the climate and that action is required at an international level. And so the Rio Earth Summit in 1992 was a major landmark conference bringing together world leaders to begin to set policies and actions in train to tackle our emissions and to stabilise the climate. Not a lot happened in the following years, and then in the UK there was a Royal Commission on Environmental Pollution that looked at the matter of climate change and recommended that we have a 60% reduction in UK emissions by 2050. And it's the first time that a kind of a quantitative target has been clearly built rather than a general case for action. Then Sir David King, the government's chief scientist at the time, argued in the wake of the 9/11 events that rather than terrorism or international conflict, climate change was the most dangerous threat facing humanity in the 21st century. This built up to pressure on the Copenhagen meeting of the United Nations Framework Convention on Climate Change in 2009, 10, the end of 2009, and then the Rio +20 summit just last year, again a major meeting of world leaders. I think it's quite startling to note, with all of these different events and discussions and recommendations and specifics, say for this 1 year, a small blip due to the economic downturn, we've seen a continuous rise in CO2 emissions. We've got a bit of gallows humour in the office at the Tyndall Centre when someone pointed out that Rio +20 might as well have been Rio +20 gigatons of CO2 emissions per year. So, emissions have continued to rise at increasing rates, and last month, atmospheric concentrations reached 400 parts per million by volume of CO2 for the first time in several 100,000 years. And this is where we find ourselves. So what would we expect for the future? Tracking that trajectory of discussion, economic growth, and very little kind of impact of a major global economic downturn. Well, what we know about is that the sources of these fossil fuel and cement emissions are primarily from the energy system. And the parts of the energy system, the infrastructures that construct it, have very long lifespans. So we know something about the next couple of decades because we know about the infrastructure that's there already. We know how long it lasts and how long we would expect to get an economic return from it. So supply technologies, and by this I mean power stations, refineries, wind turbines and the like, have lifespans of the order of 2 to 5 decades. Large-scale infrastructures like roads and railways, airports, and the built environment, the buildings that we inhabit in our daily lives that we go to work in, they have even longer lifespans associated, 30 to 100 years. And even the small stuff, the mobile stuff, the aircraft and the ships, they can have very long lifespans, the order of 3 decades or so. And so we know something about the future because we know about where we are at the moment. And we also know that there are current emission plans on the table, mitigation plans on the table from the negotiating procedures. And so my colleague Professor Anderson has been through and looked at projections of what our likely emissions trends are. And we're currently beyond the top end of the worst case scenario that the Intergovernmental Panel on Climate Change has modelled, the IPCC scenarios. We're looking at emissions, cumulative emissions, total emissions of the order of 3,000 gigatons of CO2 in the first half of the century and 5,000 gigatons over the whole of the century. And when you put this quantity of emissions, and it's the total quantity of emissions that matters, it's the area under this curve, not the height of the line at any point, that causes climate change. We put that total quantity of emissions into the climate models, we're looking at something between a 4 and 6 degrees average temperature rise. Now previously people had been concerned about peak oil, about the idea that we would not have enough fossil fuels available to us to continue with industrialized civilization. But it's become recently clear that the constraint is not on the availability of the fossil fuel. The current proved fossil fuel reserves are far exceed the safe carbon budgets that we would have to meet if we want to give ourselves a good chance of avoiding dangerous climate change. An outside chance requires peaks in the by the end of this decade at a global level. And the longer that we leave that peak, the steeper the reductions become, and the deeper the reductions have to become. And this is, remember, this is the fossil fuels budget. What we've done here is subtracted for land use change for agriculture on the assumption that that's something that we just simply can't live without, but we have some choice over the way we use energy and the way we construct our infrastructures and the like. So, the global context of climate change at the present, the view from the International Energy Agency, which is typically regarded as quite a conservative organisation. Last year, their chief economist, Fatih Birol, said, when I look at this CO2 data, the trend is perfectly in line with the temperature increase of 6 degrees Celsius, which would have devastating consequences for the planet. And then according to the World Bank, at just 4 degrees Celsius, there will be water and food fights everywhere. The consequences are very substantial of where we are at the moment. And remember, this is with some degree of mitigation. This is not doing anything at all on climate change. These are the modest, read ineffective, mitigation plans that are on the table so far. So returning to 2 degrees Celsius, let's think a bit more about that target and about the inconsistencies in our UK's target. So we have repeated commitments to hold below 2 degrees Celsius, not to rise above 2 degrees Celsius, not to exceed 2 degrees Celsius, because this has been associated with a dangerous degree of climate change. And so taking the scientific basis, the IPCC wording, this seems to match up with very unlikely to an exceptionally unlikely chance of exceeding 2 degrees Celsius. And so the IPCC recommends that those wordings correlate with a 10% chance, a less than 10% chance of exceeding 2 degrees Celsius. So the question is, well, what emissions policies do we have in the UK and what probabilities are they based around? Well, the UK government's pathway that's been adopted under the Climate Change Act and with the budgets that have been accepted by the past government and current government, we've got a pathway with a 63% chance of exceeding 2 degrees Celsius, which is quite different from the intentions of the wording at the international level and the national declarations. So a carbon budget for a 63% chance of exceeding 2 degrees Celsius is more than twice the size of one that would give you a less than 10% chance of exceeding 2 degrees Celsius. The UK government's legally binding carbon budget is twice the size of that accompanies our explicit international commitments on climate change. We are a very long way from the rhetoric in reality. And the implications of this are very substantial for the policies that sit within that. Oh, bit of jargon here, sorry. Annex 1 nations, OECD, Annex 1 nations are the nations with targets under the international regime. And that broadly maps onto the OECD nations, the economically developed, the global north, the richer parts of the world. So the graphs that I showed previously for global emissions, there is a strong pragmatic and an ethical case that reductions will be made first and will be made strongest in these richer, more technologically advanced economies. And 2 degrees Celsius mitigation for these economies looks at the order of 10% reductions in emissions year on year from where we are now. That will lead us to about 40% reductions by 2015, 70% by 2020, and greater than 90% reduction by 2030. And the reason that we have this steep trajectory is because we've left it too late. Had we started taking action in or around 1990, it would have been a much more marginal problem that we were dealing with and a much more marginal set of policies required. This is kind of reframed into a much more radical and urgent requirement of our mitigation plans. So what we can see is that this change here, this is too early for the supply side of the energy system. This is too early for new large-scale infrastructure like carbon capture and storage, like large solar arrays with high-voltage international interconnectors, like nuclear power stations. Those supply-side investments, they won't realise emissions reductions in the period of time that's necessary to do so. In the short term, what we need to do is to reduce demand, and we need to tackle the demand for energy per se. Any reductions that we make on the demand side, those savings get magnified as you go up through the supply chain because of all of the inefficiencies in the way that we distribute energy vectors. So fossil fuels, liquid fuels, or electricity coming down the wires. If we make savings in the amounts that we demand in our own businesses, in our own houses, then we multiply the effects of that and help to make substantial changes in the short term. And then that gives us the chance that in future, the supply side investments and the decisions that we take now, when they're constructed and they come to fruition, they give us the possibility of pushing down here to very low quantities of emissions from our energy system. Now, so if you think that 2 degrees mitigation challenge looks too difficult, well, what does the alternative, what does the 4 degree future look like? Well, for 4 degrees, we would still need emissions to be peaking around 2020 and be looking at a 3.5% per annum reduction in CO2 from the energy system in any case. So this is some degree of climate policy, broadly the climate policies that we have on the table at the moment. And such a reduction rate is eminently achievable. So is this a more realistic target to adopt and to work around? Well, the key thing that we need to recognise when we're talking about the difference between a 2 degree and a 4 degree target is that that is simply an average metric of the global mean surface temperature as a whole and doesn't represent the consequences of any particular locality. So for instance, that would suggest a 5 or 6 degrees warming on land, given that we are a blue planet, and the mean over the seas influences the mean of the globe. And so we would anticipate a higher degree of impact on land. And then not just the different localities, but also the extremes of weather events. And as an example of this, these statistics come from the Department of Energy and Climate Change and the Hadley Centre work done a couple of years ago, modelling a 4 degree globe and visualising that. And they found that on the hottest days, central China might see increases of 6 or 8 degrees above present temperatures. And it might be of the order of 8 to 10 degrees in Central Europe. Or potentially, and this is staggering, of 10 to 12 degrees in New York. And this is on top of what we are accustomed to as a hot day in any case. And that has substantial implications for other systems, not just for how we might imagine travelling and living and working, but also for the agriculture system that underpins our civilization. And so in low latitudes, it's anticipated that there would be 40% reductions in maize and rice yields. And that has profound implications as we're heading towards a population of 9 billion by 2050. So there's a widespread view that 4 degrees is incompatible with an organised and peaceful global community, because it is simply beyond adaptation for many, especially the poor. It's also devastating to ecosystems, and this is compounded by the fact that CO2 dissolves in the seas and changes the acidity of the oceans. And that pushes us to a situation where we have less knowledge and less confidence in the stability of the climate as it heats up, as to whether we move towards feedbacks in the system, popularly called tipping points, where the climate doesn't stabilise at a higher level, but carries on and would spontaneously increase in temperature of its own accord, even if we left it to its own devices and ceased putting greenhouse gas emissions out. And so the only kind of sane conclusion I think you can draw from this is that 4 degrees Celsius should be avoided at all costs. And so we come back to this 2 degree mitigation. And we're stuck in this situation with 2 impossible futures. Is living with a 4 degree global temperature rise any less impossible than actually getting on and making a difference and changing the way we use energy and the way we organise our lives and our economy? And so I don't want to leave this here in kind of a moment of despair, because we have got the agency to achieve these reduction rates and give us something of a chance of avoiding 2 degrees Celsius. And so yesterday, the International Energy Agency reiterated the importance of what we do in this next 10 years in terms of the commitments that we make to infrastructure and the ability to change our emissions future, our future trajectory. And what they did was they outlined 4 actions that would offer significant global reductions by 2020 and would be a bridge to a wider transformation. And their number 1 that delivered 49% of the savings that they identified was to adopt energy efficiency measures. And these are no-lose measures. The energy efficiency increases, has positive benefits in a whole raft of different avenues. And I know Andrew's going to tell you a little bit more about some of those at a local level. Limiting coal power stations, the types of new coal power stations that are built. Minimising methane from the oil and gas industry and phasing out subsidies on fossil fuels. Okay, so these are 4 things that are quite contained, quite targeted, and that would really kind of begin to move us away from the 4 degrees trajectory and begin that wider transformation. And so this is a quotation that my colleague Professor Kevin Anderson trots out with tedious regularity for those of us who have to sit in meetings with him day after day. But as much as it gores me, it's actually pretty profound, and it does bear repeating. And so Roberto Unger argues that at every level, the greatest obstacle to transforming the world is that we lack the clarity and imagination to conceive that it could be different. And that's what I think Councillor Scott and his colleagues are beginning to talk about, is beginning to think about how things could be different, and to be able to imagine that alternative future that doesn't take us down 4 degrees Celsius pathway. Thank you.
We're just going to go straight on to Andrew Wilson's presentation, then, so when we start discussing, we can really listen to it.